Welcome back to another video. So generative AI has advanced a lot, but I want to showcase that it will still take time until this kind of solution will be able to output quality meshes that are comparable with CAD. And this is the case study. We have over here a Lego car. So this was actually taken within SolidWorks as a print screen. And this will be the car. And I added that within Spark 3D. And the output will be the following. So if I'm going to zoom in the car, you're going to see that this will be the output. Now we see that some Lego parts are defined. For example, over here we have those round elements, but just take a look over here at the details on the original car model and the one outputted by generative AI. Over here for the hood, this also had various gaps, as we can see over here, and the output will be like this. Over here in front, there are some changes. We see over here for the lights also various changes. Now, while I'm rotating over here, this went into not responding. I also have the model loaded over here within 3ds Max, and this was converted and brought in towards Blender. So usually it should work. I'm not sure exactly why it's lagging now. So this is the image that the generative AI used. And let's see if Blender will manage to somehow recover from this. Because we see the high amount of details over here, and more specifically within CAD, we can measure accurately. And this is something that generative AI will need to start to be able to output. So if I'm going to zoom in over here, I'm going to see the following. If I want to measure, I'm going to find over here the diameter, the perimeter, and also the area for that component. It will be the same for the others. So if I'm going to do the same over here, we see a diameter of 5 millimeters, and we're going to have that area as well. If I want to measure a distance between different components, I can also do that. So this is why generative AI will need to start to work with real measurements. And this is why CAD is so important compared to just 3D, so polygonal meshes. We see over here various dimensions regarding this. So it's highly important for generative AI to be based on real measurements so that the outputs will be, let's say, reliable. So we can further go ahead and use those within various outputs. We see over here those distance, so that length and that segment again. This is something that is kind of, let's say, impossible at the moment. There are some generative AI tools like Zoo that started to implement some similar approaches, but they are still far away from that. If I'm going to check over here the statistics, we're going to see that this CAD model converted from SolidWorks will be defined by less than 500,000 faces, and we see how many details are present over here. While for the other model generated by generative AI, it has 2 million faces, so already 4 times the number of faces of the CAD model, but it's just lacking details. And most importantly, everything is stitched together. So some tools have started to implement segmented meshes, but the automatic segmentation is not that good. So, for example, for a car, maybe the tire and the rim will be separated, but that's about it regarding that. If you want to go further along into details, into small components, generative AI will not be able to do that yet. So maybe within the near future, it will manage to output that. But we see over here all of those fine Lego details for each component that will be brought in from the CAD solution. If I want to go over here onto the local axis, we're going to see how that part will slide in and out. And this is why tolerance and dimensional tolerance is really important for 3D modeling. And I really hope that within the near future, they will start to develop similar features for this. Let's see, I also want to remove over here all of these materials. So they've been brought in from Solid. I have over here a script, and I'm gonna run that script. If I'm gonna go back onto the layout, I think that this is more eloquent. Let me also enable cavities so we can better visualize the model. So we see the one on the right is a CAD model, the one on the left is generative AI. If you're just gonna take a look like this at them, even this model looks pretty good, but keep in mind that on the CAD model, everything will be smoothed, everything will be rounded, as we can see over here, and we have a lot of details. And still, this mesh has 4 times less the total number of faces than the one over here. Regarding the total number of vertices or points, we have 1 million on the generative AI, and we're gonna have 466,000 for the other model. So let me know in the comment section what is your opinion regarding this. When do you think that generative AI will start to output good models in terms of, let's say, geometrical tolerances and so on? Because we already have those mesh segmentation, but everything is not at a true scale. We need to go ahead and further scale those so that we can use them within various outputs. Okay, so I hope you enjoyed this kind of content. I'm going to position a similar video on the left side, and I will also add a subscribe button to the right. So that's it. Thanks for watching.